Welcome to this explainer. If you've ever felt like deploying a large language model into production is basically rolling the dice, you are absolutely in the right place. Today, we're diving into a really fascinating challenge: how to build a robust CI/CD pipeline specifically for AI applications. We're going to explore the architecture, the infrastructure, and the implementation roadmap to make your AI deployments just as safe and predictable as traditional software. Let's kick things off with a slightly provocative question to frame our core problem. How exactly do you test software that changes its answer every single time? Traditional software is deterministic, right? It gives the exact same output for the same input every single time. But large language models, they're probabilistic. They operate on probabilities, which makes them inherently unpredictable. Here is our roadmap for this explainer. We'll start with the AI testing problem, then move into defining AI regression testing. After that, we'll look at data sets, specifically golden versus random. Then, we'll break down the LLM as a judge approach. And finally, we'll wrap up by building out the actual CI/CD pipeline. All right, part one, the AI testing problem. Let's establish the baseline difference between deterministic code and probabilistic AI. Think of traditional unit testing kind of like grading a math test for exact answers. You build your code in an IDE, and you validate it with strict assertions. Testing LLMs, however, requires entirely new tooling and environments. You author prompts in playgrounds, and because the output is so fluid, you validate those prompts using complex evaluations. It's just a completely different paradigm. And this is exactly why traditional automated metrics fit a brick wall when dealing with AI. Older metrics, things like Blue and Rouge, they basically just look for exact word overlap against a reference answer. But imagine a user asks a chatbot for a password reset. If the AI says click settings instead of navigate to preferences, a traditional deterministic test will falsely flag it as a failure because there's literally zero word overlap. But in reality, both answers are perfectly correct. Probabilistic generation absolutely breaks deterministic metrics.
Moving right along to part two, defining AI regression testing. Let's see how this builds into our testing framework.
In the traditional software world, a regression usually means, broken syntax or an application crash. But in the AI world, regressions are silent and they are incredibly tricky. We're talking about subtle quality degradation, a weird shift in tone, lost context, or hallucinated facts. An output that is silently wrong is actually far more dangerous than a loud error message, simply because it seamlessly passes through the system straight to your user or your database. And this concept brilliantly illustrates the risk. When an AI uses what researchers call a hunter call, meaning it's specifically hunting to fill a fixed schema slot, it feels this immense pressure to complete the task. Even if the data isn't clearly present in the source document, the model will often confabulate or hallucinate plausible values for absent fields just to satisfy that schema. That right there is a silent regression, and it's exactly what we need to test for. Which brings us nicely to part three, data sets, golden versus random. We have to figure out exactly what data to use to ground our tests.
You can think of a golden dataset as your ultimate answer key. It's a statically defined, version-controlled repository of representative inputs that are mapped to manually verified, absolutely perfect target outputs. A well-curated dataset of maybe 100 to 300 complex scenarios acts as a solid, mathematically defensible standard for managing the risk of your models.
But you really can't rely on a golden dataset alone. While golden datasets give you incredible depth, precision, and baseline protection against regressions in high-value scenarios, they are static. That is where random sampling comes in. Random sampling gives you breadth. It captures real-world user behaviors, helping you discover completely unpredictable edge cases that you never even thought to test. A mature enterprise strategy absolutely requires both to balance precision with real-world realism.
All right, part four, the LLM as a judge approach. Let's explore how we actually score these answers automatically.
Remember how we said exact word matching fails? Well, LLM as a judge solves this. Much like a teacher grading an essay for its overall thesis and structure, we actually use advanced AI to score another AI. It evaluates the meaning, the intent, and the relevance of the output. We can measure qualitative metrics like hallucination, context precision, and answer relevance to get incredibly accurate automated scores. By integrating tiered F1 score thresholds directly into your deployment gates, your CI/CD pipeline can make autonomous decisions. For instance, if an output falls below a high-risk target of 90%, it triggers a warning.
If it falls below 80% on critical data, the deployment is blocked entirely and requires mandatory human verification.
What's really fascinating here is how we can take this evaluation even further. Researchers have found that comparing two structurally asymmetric AI calls can act as a hugely powerful confidence signal. Say you have a hunter call looking for specific fields, which we know can cause hallucinations, and a mapper call that holistically scans the document, which might miss things but rarely hallucinates. When these two different approaches disagree, it highlights genuine extraction ambiguity.
We can even go beyond text and evaluate spatial features. For document AI, we can literally measure the physical distance between where the models pulled data from. If they pull data from entirely different spatial regions of the document, the system flags it as unreliable, even if the text somehow matches. It's an incredibly robust way to prevent silent failures. And finally, Part 5, building the CI/CD pipeline. Let's pull all these concepts together into a practical implementation blueprint.
Here is your golden rule pipeline. Never push a prompt straight to the main branch. Instead, Step 1, author and iterate your prompts in a playground. Step 2, run your automated LLM as a judge evaluation gates against your golden data set. Step 3, deploy to a staging environment and review the pull request. And Step 4, only once it passes all those strict checks do you actually merge and deploy to production.
But the work doesn't stop at deployment. You need continuous observability. This feedback loop ensures that you trace live production calls, flag those interesting examples that receive low scores or user thumbs downs, and promote those failures directly into your golden data set. This creates a powerful flywheel effect, continuously hardening your baseline against future regressions.
And when you do deploy, you absolutely want to use safe deployment strategies. For high-risk updates, use a shadow deployment. This routes live traffic to both your current agent and the new agent silently in the background. The new agent processes the request, but only the old agent replies to the user. This lets you validate probabilistic variance on real-world data without risking the user experience. If there's an issue, your automated rollback catches it instantly. The results of this kind of rigorous architecture are just astonishing. By utilizing a selective prediction system, intelligently routing just the bottom 20% of low-confidence predictions to human review, your automated CI/CD pipeline can achieve a staggering 99.1% accuracy on the rest. You maximize automation throughput while maintaining incredible safety.
Ultimately, your observability layer has to connect these technical metrics back to the business. Engineers love tracking token counts, sure, but business stakeholders care about the cost per task. By setting cost alerts and tracking the cost per resolved ticket, you can definitively prove the real-world ROI of your AI agents.
So I'll leave you with this final thought so you can audit your own systems. Take a hard look at your CI/CD pipelines and ask yourself, are you truly testing for intelligence, or are you just testing for syntax? Implementing golden datasets, LLM as a judge evaluations, and strict deployment gates is exactly how you transition from treating AI as an unpredictable black box to a manageable, auditable microservice. Thank you so much for joining this explainer, and happy deploying!